Looks like we're almost done with this lecture. So let's go ahead and finish strong. And I should hopefully have a small set of slides to start talking a little bit about sampling. There might be some redundancy with what we talked about with surveys, so hopefully it'll be pretty short, but it'll be a nice refresher for what you got before spring break. So let's talk about some of the issues with observational research. Can we draw any causal conclusions from it? Nope, not at all. Remember, we're not actually manipulating anything. We're only measuring what is there. Behavior is too complex. It's very difficult to isolate variables. You were probably not present for some of those variables, and there's very, very little control. But you can anticipate possible alternative explanations for findings and rule those out, like the study by Crowley and colleagues. So, for example, it was suggested that that it was important to look at different age groups because it was possible that you would see that you wouldn't want to give a scientific explanation to a child that was 1 to 3. So maybe there wouldn't be any gender differences there. And so they looked at age to rule out that possible alternative. Likewise, another alternative explanation could be that fathers don't explain science very well to girls, but mothers certainly do. So by dividing up their data into fathers, mothers, and both, they actually showed that this gender bias persists not only across all age groups, but with every type of familial structure, whether fathers on their own, mothers on their own, or both parents being present. So if you can anticipate possible explanations and rule them out with the way that you collect your data, you can narrow the potential cause-effect relationships that might be in play. Now, something that we definitely have to watch out for is observer bias. Your expectations can absolutely bias how you observe or code your behavior. If you're looking at people with psychiatric disorders, for example, you might basically code all of their behavior, innocuous or otherwise, in terms of their disorder. And that will affect how you code your behavior. That is especially true when you're looking at behaviors that might be ambiguous. So you can alter how you choose to sample that information. So, for example, if you're looking at healthcare in rural areas, one of the things that we know about healthcare in rural areas is that there are multiple factors that are involved here. Generally, people in rural areas tend to be older, they tend to be poorer, and as such, they tend to have less access to things like public transportation, parks, good walking spaces, and things like that. And so if you're looking at health in rural areas, you have to very, very carefully consider how you are sampling that information. You don't necessarily want to select everybody in your sample of observations that confirms everything that you believe about healthcare in rural areas. You want to try as much as possible to get a good sample, looking across as many age groups as possible in a rural area, income levels as possible, so that way you aren't necessarily keeping your observational sample with people that basically confirm all of these ideas that you already have about rural health. There we go. So what are some different ways that we can reduce observer bias? If you are coding behavior or if you're using a checklist, make sure that you have clear operational definitions of the different behavior categories, like we saw for the Little League example. Have multiple observers that are well trained. And once you've trained them, give them an opportunity to practice and make sure that we have a lot of inner observer reliability. Additionally, for people who are observing, it's even better if you can make sure that they don't know anything about the hypothesis that you are trying to test. They are just there to observe. So make sure that whenever possible, you're using a blind observation. Now, there are some issues with reliability. What happens if we do find that observations between two different people are different? It could be randomness, but it could also be observer bias. And so in this case, to help kind of rule out observer bias, we need good interobserver reliability. By and large, our observers need to agree in their measurements. And you can measure interobserver reliability pretty well through a correlation coefficient. So we want to make sure as much as possible that our correlation coefficient between two different observers' measurements are pretty high. Other things that can help enhance interobserver reliability include a good, clear coding system, as well as sufficient training in how to code that data. So here are some other things that we can do. We need to have clear definitions of observer categories. The categories should not overlap. They should be mutually exclusive. We want to make sure that we don't have too many categories. And we need to make sure that we have training. People need time to very carefully study the coding system. We give them hands-on instruction. We give them practice testing, and we give them feedback. One of the things that I've kind of seen when I do AP grading, I actually get feedback on my scoring methods from what we call a table reader. So there are about 8 people that are scoring exams at a table, and each table has its own leader that basically randomly selects some of your scoring, and she or he also will score the response. And they're usually very well trained at AP scoring. So if they say, you were kind of harsh on this, try to kind of lighten it up a little bit, or you were too easy on this, be a little harsher. You can get that feedback that you need to make sure that people in your table are being consistent with their scoring. And I actually think that's pretty cool. Now, there is an issue of reactivity. People behave differently if they know that they are being watched. This is an older picture of Earl, my cat, hanging out around his cat tree. And right before I took this picture, he was standing upright. And what he was doing at that point was he was standing upright with his paws wrapped around the pole, and it was almost like he was hugging it. And as soon as I tried to take a picture, he did this. So he changed his behavior because he knew I was about to take a picture. This can happen in any type of study. This can happen in an experiment. This can happen in a survey. In general, reactivity is always going to be a possibility. Now, it's not guaranteed to occur, but as often as possible, we should try to guard against it. And this is a case where disguised observation can absolutely help. Additionally, take advantage of the fact that when you're in this new situation and you're watching somebody, take advantage of the fact that habituation is something that will happen. People will get used to the scenario that they're in. They will become more familiar with what they're supposed to do. And so don't take observations right away. Give your participants time to acclimate before you start taking those observations. Now, finally, we're going to close by talking about some different types of unobtrusive measures and archival data, which are also technically types of observational research. So unobtrusive measures are when you are assessing behavior without making other people aware of what you're doing. Now, it's not a black or white distinction. It tends to exist on a continuum. So some examples of unobtrusive measures include disguised naturalistic observation. You can also look at what are known as physical traces. So for example, when I first started teaching research methods, instead of doing a replication study, I had participants do different types of labs. So they would get a survey lab, they would get an observation lab, or an experiment lab. And for the observation lab, I wanted them to do some type of observational data collection in the dining hall. And so one of my students actually had a really cool idea. She wanted to look at whether or not people were more likely to finish their food or leave food waste, depending on whether they took that food from the salad bar, the dessert area, soup, or the hot bar. And so she did this in a really interesting way. Now, she could have easily walked around different tables and watched people as they were eating, but this was actually probably a better idea that she had. She went back in the kitchen where people drop off their trays and took account of the food that was left on people's trays, and she would mark where it came from based on what was being offered that day. And that's a case of physical trace. We're looking at what people leave behind and learning about their behavior from that. Another type of unobtrusive measure is when you have a study in which people are aware that they're in a study, but not what you're actually measuring them for. So many of you that have been in my classes have had the awareness test where you're supposed to count passes made by people on a basketball team, and it turns out that's not actually the purpose of the study at all. The true purpose of the study is to look at inattentional blindness. A bear walks across the screen and moonwalks, and oftentimes people who are busy counting basketball passes will fail to notice the bear. So that's another case of an unobtrusive measure. Another thing that we can do is archival records. We can look at previously existing documents or data that are produced independently of our current research. So we can look at newspaper articles, we can look at government documents, we can look at media. And so, for example, if we wanted to look at how gender roles have changed over time and we wanted to look at archival data, there are some pretty easy things that we could do. We could look at old newspaper advertisements over time and see what kind of aspects related to gender roles are there. We could look at old women's and men's magazines and look at what common themes pop up over time. So we can look at archival records and older print media, different types of media or documents to learn about these things. And what's cool about looking through archival data is that typically many types of archival data actually are exempt from IRB review. And that's pretty neat. So, folks, this is all I had for at least for this week. I am going to start posting a few things on sampling because I want to make sure we don't fall too far behind our schedule. But I hope that you're doing well. I miss you all very, very much, and I hope you're staying safe. Take care of yourselves, take care of each other, and I'll see you soon.